Yeah, we are live. Good afternoon, everyone. We're really happy to see that you are enjoying the GConf Central America 2020. Today, I have the honor to present you one of the speakers international that has a good career as a Java developer. Her name is Mary Gryglesky, and I'm going to present make a description about her. She is a senior developer advocate in IBM with a specialization in Java Reactive, open source, cloud, and system distributions. The topic that she is going to talk with us is deploying a modern serverless reactive microservice to the cloud. And I'm not going to entertain you. I will leave you with her. So we'll start. Mary, the stage is yours.
Thank you, Michelle. I appreciate you giving the introduction. Yes. Now, if anybody find me talking too fast or not understandable, please feel free to type on the chat, and then Michelle can tell me too.
I tell you,
I'll be
don't
slow,
worry.
Right?
It's
okay.
yours.
Okay. Thank you. Okay, great. Thank you. Okay, so I'll start. So my talk today, right, the title is actually deploying a modern serverless reactive container to the cloud, or reactive. I forgot to, I might have also written as reactive microservice. Not to say microservice and container are exactly the same, but in some sense, though, they are kind of interrelated, obviously. In today's cloud computing, the modern world, everything we're managing, all of the, the services in your cloud, they are containers. And to me, containers are a bit more like a physical explanation, right? And in some sense, right? Not really exactly, we don't really see the physical part, but it's more like container is we can create them. It's more of a tangible kind of, you can kind of almost see it, kind of more concrete type of instance, right, in your service, in your process. But whereas like microservice is a bit more abstract, it's more about architecture, as we all know. Microservice is, there's no like one single thing you say, create microservice or something. It can be any type of implementation, but it's more abstract, it's more conceptual. You're creating services that are smaller, more bite-sized, but also like more concise, has a single purpose. They are within the larger ecosystem type of connotation. So anyway, I just thought I'd point that out, because even sometimes I forgot to, when I go as an advocate myself, I talk at a lot of different conferences, and then I talk kind of similar topics. But I also have to be careful how I describe things, so I want to be kind of more clear to everybody. Now, as such too, today I will touch upon using this Vertex, for example, for like the deployment part is a Vertex component. And as we all know, Vertex is a reactive toolkit, reactive library. So I would spend more time talking about Vertex as the reactive container. And then the thing is with deployment too, is that I also put in like Red Hat and also IBM Cloud. And so Red Hat is the one, as you know, IBM and Red Hat are now one same company. So Red Hat has their Openshift. Essentially, Openshift is a Kubernetes-based cloud container orchestration platform. It makes use of Kubernetes underneath the hood. So think of more like Kubernetes has more features to it. Red Hat folks kind of enhance it and make it more features and more manageable for this platform. So, and actually, if you're interested too, I will give you information on a workshop that I will be doing with a colleague in 2 weeks. That it's free workshop, and we are same time zone. You're welcome to join. So I'll give that information to you. So if you want to learn more about Kubernetes and OpenShift. Anyway, so the deployment platform today too will be to IBM Cloud. As such, I work for IBM, so there's IBM Cloud, and I invite all of you to also get a free account. It's all free. No need for a credit card, for the free tier access. So, okay, so that's it. And so now, thanks again, Michelle, for introduction. So no need to go too more deep. So as such, right, I want to spend a bit of time because especially when now I bring in the reactive side of things, I have to make some assumption that not everybody has worked with reactive yet. So I want to highlight a little bit and give a bit of a background information first. So then it's a bit more clear. Because today, as you may know, when you look into like the internet, searching for cloud, searching for application, it's always so many things floating around cloud, containers, cloud native, all of these things. They kind of all becoming, especially when you are busy working on some existing systems that are not in the cloud yet, it can become very confusing. What is what, and all these things. But anyway, the point I'm trying to make is that with my talk is specifically, I highlight the reactive because this particular component is making use of a reactive way of doing things. So I'll give you some background of reactive, so then you also can be familiar with it too. Okay, so as such, as I mentioned, I'm picking selecting Vertex, and as such too. Actually, you know what? I should kind of give a bit more more information to you as far as a diagram goes, because I don't think I have it in here. That want to give you a bit of a background information. Over here, I'm just going to be sharing this for a second. This slide, because actually I have that too. I'm sorry. Sometimes I kind of like get everything all kind of like confused. But anyway, okay. I may just advance it a little further down to this and this one. Okay. So just wanted to give you a bit of an this current state of the market right now as far as reactive frameworks and toolkits go. So like I said, I will be talking specifically talking about Vertex. And the thing is, Vertex is only one such libraries, and it's reactive, provide the reactive capability. And then there's also some of you, if you're doing Android, you probably are very familiar then with RX reactive extension, RX Java. And then there's also MicroProfile. MicroProfile is is more catered for microservices type of purposes like reactive capability. Now, the way the MicroProfile it's actually has the reactive functionality to it is basically making use of this library called small rye, like it's up there too. I was showing you the small rye. So I will talk a little bit. I can talk a bit too about that. And then there's also Akka. If some of you may also have worked with that, it is the Lightband reactive library toolkit. They don't call themselves exactly like framework, but it's more library. And of course, that it's originated from Scala. And Lightband, the company started by Dr. Martin Odersky, the inventor of Scala. So the Akka, Play, and Lagom are very sophisticated set of libraries for you to build reactive systems too. And then there's also like Project Reactor, which comes from VMware, what used to be Pivotal. So those are kind of like the major thing. But like I said, I'm going to be talking more about the Vertex today. So this way, kind of like give you a bit of a background too. Okay, let me then go back. So why Vertex, right? Vertex is an open source project by Eclipse Foundation. So as such, all free, you can use it, kind of quite quickly. Reactive in nature is event driven. When we talk about reactive, it's really the asynchronous way of processing, which is different than traditional way. When we talk about asynchronous, really what it is a non-blocking way of processing. Non-blocking meaning that you have requests going into a system. Traditionally, too, when we write code, for example, when we're making use of in Java, we're doing like if then else and doing all of these things and processing, right? You come in, you want to kind of test to see what it is, and then you do the processing accordingly. You go through, you iterate, right? The iteration, the list, all those things, they are blocking calls. They're traditional way. So you kind of go through the list, and in the meantime, when it's looping through everything, your whole system, the main thread is being put on hold. That's what like blocking means. So it's like blocking, but Vertex too make use of an event bus, and the event bus is what kind of enables it to be, to kind of enable the asynchronous style of processing, because you can have request coming in and it has an event loop. It's just basically pick up the request and it handles it accordingly. So then, other requests comes in, it doesn't have to wait. Think of yourself, right? Going to a restaurant, you want to order food. You're doing shopping, you're hungry, you order food. So they give you a ticket and you go off with your ticket or beeper or something and kind of notify you. You kind of decide, let me go shopping while the cook is preparing food. So same kind of like concept, right? So except that we are now dealing with systems. We're dealing with computers, computing in a computing sense. So anyway, so that's a bit of a background. And of course, too, Vertex, I kind of love talking about it because it's really the engine behind the scenes for Quarkus. Quarkus is the, if you're not familiar, that's the newer library that comes out, is cloud native ready. So it's very, and it comes from Red Hat. So it's basically worked very well with Openshift as well. And it doesn't have to be all Openshift either. But the thing is, it's a very efficient library for you to build cloud native ready application. On the build side, is basically streamline your applications. So what used to be, when you build, right, you produce your jar file, WAR files or something, it basically trims down all the unnecessary parts and make it, your executable very small, very kind of efficient in that sense. And as such, it's all cloud native ready. So in today's world, it is definitely a very step ahead type of library that we should all be paying attention to. So okay, so Vertex is really what kind of goes behind the scenes for Quarkus, and very lightweight, very simple toolkit. And I wouldn't call it, they like to say it's simple. Of course, nothing is simple in the computing world, but in terms of when it compares with how things used to be done, it has become simpler over the old ways of doing things. So that's what it is. And it's very flexible and also very polyglot nature. So I'll show a bit of code into how it supports like polyglot in Vertex. Interoperable because it supports like Reactive Streams, which is an initiative, a specification that specifies how do you handle non-blocking asynchronous processing streams. And so then, it prevents like back pressure from building up, right? So a concept in reactive processing, very important, is to handle back pressure. So back pressure essentially are too many requests. If I describe it just like layman, you tell somebody who doesn't, have as much computing knowledge, it's more like, okay, you get too many requests coming in and whoever is handling the request can't handle it all at once, right? So then you kind of backfire kind of thing. So that's kind of back pressure. So essentially too, all of reactive, it's kind of handling all of these things, concurrency, things like that. So basically, to me, opportunities are unlimited. You can build your applications in any way you like. And it being a polyglot nature library, you can actually be building, let's say, a system. You want it kind of loosely coupled, right? Nothing tightly coupled. You can actually essentially build pipelines of data that flows through it, one after the other. If you conform to a specification like Reactive Streams, you can have source and output. So the output will get fed into another pipeline. That's maybe I want to implement, or some older stuff is in Spring or something. Not to say Spring is old, but let's say we're using an older implementation of Spring. You have that built in Spring, the reactor. And basically, you have Vertex and you want to feed the data in. You can basically kind of connect like different pipelines into your application, for example. So opportunities are really limitless in that sense, right? So now, okay, I spoke a little bit already about reactive Java, so let me kind of go a bit little further. It's to bring up the Reactive Manifesto. So for reactive, we're talking about reactive programming. So the programming part is what we write the code. Let's say in a microservice, we are implementing a microservice. It's like a component that handles things. We are making use of the functional way of doing things, functional style of programming. Now, that's not the same. Functional programming, strictly speaking, is not the same as reactive functional programming, because functional programming, it deals more with the lower level stuff. It deals with, let's say, your thread of control, right? Anybody that's doing functional style of programming, we understand what that is. And so it's more like your thread, the movement of your data is according to the thread. So your thread is processing something, and basically your whole program flows like that. But for reactive too, is that it's really the data, the change in state of your data. So event carries with it some data. The state of the data changes, and that's what kind of trigger the flow in your reactive pipeline. So that's reactive functional programming. So it makes use of the functional style of way of doing things, and that's what reactive functional style is. Okay, so let me go back here. I just want to make some distinctions so that it's kind of a bit more clear on, as far as what is what. We tend to use terms interchangeably, and not only that. For now, we are talking about Java, but the thing is too, in JavaScript world, there's also React framework, React.js or React Native, which is the mobile support, right? And so this talk is about reactive Java library, but the thing is, concepts applies to everything. But as far as the implementation, all these libraries, of course, we're talking about Java in this case, but the React.js is JavaScript implementation. And also, too, they may not be exactly respecting the Reactive Manifesto, which I'm going to be talking about now. So Reactive Manifesto is a set of guidelines, essentially 4 core tenets of what reactive system should be. This manifesto was essentially put together by the Lightbend company, Dr. Martin Odersky, the Scala company. They defined a reactive manifesto and basically outline what reactive systems should be. Essentially, they need to be responsive, which means any kind where you're processing a big system, a lot of requests coming in, you don't want to have any delay in your response. So you need to have a system that's very efficient, right? And so in that case, if now it's the responsiveness. Okay, so if you go left to the elastic side, that's what is meant by anytime, right? Your system is made to work. We do expect spike that can happen or high volume of traffic. Take for example, Valentine's Day, right? So gentlemen, on Valentine's Day, you want to order flowers for your girlfriend, your wife, or somebody you love. And so you go online, and then everybody's doing the same right before Valentine's Day. So you can imagine then the volume of traffic will increase. And during that time, and that's when systems, then a very reactive, resilient kind of system will need to have more, resources, right, to handle. For example, you have more orders coming in, it needs more write to a database or something, then you need to have additional pipeline that would talk to your database or do order transaction processing, something like that, right? So that's the elasticity. The system needs to be very scalable. And of course, too, if times that are slow, then you want to also return these resources back to the pool, or shut down some of the extra resources that wouldn't be needed. So that's means it's flexible, up and down, kind of grow and kind of shrink down when not needed. And now and if we look into the next one, the third one is resiliency. By resiliency, it means that if the system fails, during processing, no big deal. In terms of being reactive, is that there's got to be mechanism of handling such kind of error condition. Something that's all of a sudden taking a lot of time to process, or maybe some child process goes away, then there needs to be someone there watching. So let's say, right, in Akka system, that it makes use of like a supervisor type of tree hierarchy type of processing. So essentially, think of a tree. So it's like the parent, right, will then be notified, either be notified or some process of telling it, hey, one of the children node is off or something. Then it needs to be able to spin off another child to cover whoever was down. And so in that case, the sick child will get taken offline and maybe they need to fix or whatever. Then there will be a new component able to come in and step in and do things, really efficiently for the requests that are waiting to be processed. So that's kind of with resiliency, recoverability. And of course, in today's cloud world, it's really highly kind of making use of the cloud, the clustering, all of these that already have kind of high availability and like low balancing type of clustering capability in there. So the thing is too with reactive, it's interesting. It's kind of the timing is right in which reactive comes out just at the time when hardware is so in such an advanced state, right? There are systems that are multi-core now. What used to be single CPU or single core machines, now no big deal. There are like systems with multi-core and all these things, and that can actually truly handle like concurrency within your system. So that in that case too, then that's when also reactive systems become more prominent, because it's making use of these multi-core machines, because then there will still be threading being done, but it has threading in your user space versus in your kernel. Because if you have your processing, if you hold tied up the kernel thread, then that's when things are slow. If you think back, if you have done like say Java Swing, you probably if you are a bit more experienced programmer, you have done Java Swing. They basically, right, it's kind of a single thread kind of model. So anytime if your main thread is tied up doing some rendering, some processing, or maybe your main thread is processing something with the database, it blocks and holds it up kind of thing. So okay, without kind of going too much further, but that's what it is: resiliency, being able to bounce back. And then all of these, right, are kind of able to do its job. It's really been enhanced or enabled by the message-driven capability of the system. Now, by message-driven, it means that components are talking to each other through messaging. Message-driven really implies two endpoints, talking to each other. They know, the sender knows what the address of the receiving end is. That's message-driven, which is different than event-driven. However, when we talk about reactive, very often too, we bring in the event-driven aspect. True. So strictly speaking, the mechanism as used by an event-driven system is mostly kind of in a publish-subscribe type of relationship. As we know, if you have worked with like messaging in PubSub, it's more like producer. That source of your data comes in, right? It emits data, so that's your source. It publishes the messages or whatever needs to be handled, it publishes, and it's really up to whoever is interested in it, like publish and subscriber. I subscribe to what I'm interested in. So that's, as you can see, event-driven is that the publisher doesn't have to know, or most of the time, in fact, they don't even know what the address of whoever is going to be receiving it, because it's just basically almost seems like broadcasting. I have something, it's like watching TV. The TV producer doesn't know who's watching it. So if we want to watch something, we turn on the TV. It's kind of same concept, right? So you subscribe to it. So that's more event-driven versus like message-driven. Message-driven is like two known endpoints. Okay, so that's that. Okay, so those were the four tenets. And now, well, back to this, I already show it. So I'm going to be talking about Vertex. And then I wanted to also highlight something is about our socket. And this is Reactive Socket. It's come out of the like a collaboration between these 6 companies that started it. Facebook, as you can see, Netify, Alibaba, Lightbend, Pivotal, which is now VMware, Vlingo. And it's basically now they have formed this reactive consortium. And it's underneath the Linux Foundation, so part of the Linux Foundation kind of charter. And so Reactive Foundation is primary things right now it is doing is kind of overseeing the RSocket implementation and all the release and everything. So RSocket is essentially an open source layer 5 and 6 communication protocol based on the Reactive Streams. And so I know I'm kind of bringing in all of these things. So Reactive Streams, it's something I don't think I mentioned yet. And it's basically is a specification, or maybe I did, right? And about a specification that tells how do we manage back pressure in a non-blocking asynchronous system. And that's what essentially it is trying to do is the Reactive Streams. So our socket supports that, and is much faster. And all these things that I'm listing in here, it takes care of back pressure, flow control, and it's also very polyglot in nature. It supports like all kinds of languages and platform. Like you can primarily Java, but actually Python, Kotlin, and all these other, I believe Scala too. And it also supports those too. But without going into further detail, it's just want to give you an idea. And this one too, I wanted to also bring up is Small Rye, Mutiny. So essentially too, these are libraries that supports reactive types of operators. So now, I know I'm kind of seem to be jumping around a little bit. I'm sorry. I'm kind of a bit busy today. So I had another presentation earlier, so slightly different in nature. But anyway, still talking about reactive. So I apologize. Anyway, so I wanted to kind of bring up quickly too about this Mutiny library. This Mutiny is a relatively newer library, and it's a reactive library. As you can see, I borrowed this picture too from the documentation. So Mutiny, it's essentially handles all of the programming and streaming concern, as you can see in this highlighted block, right? So just want to give you an idea. So Mutiny too is an interesting library that actually that's what it's being used by MicroProfile to support all of the reactive things underneath the hood. So, okay, now then I get into my Vertex some more now. So and then I'll show you some example and we'll do a simple case of deployment. So okay, so for Vertex, back to Vertex. And some use cases you may be asking too, well, what is it for, right? Reactive, all these things, especially if you are new to it, you may find it a little bit kind of, too much. So just want to give you back to some practical use cases. So these are like a list of things you can essentially use Vertex for. You can write TCP clients and servers, and writing, HTTP clients and servers that include support for WebSockets. And it has this event bus, all these things, and periodic delay actions. So kind of putting a timer into your applications, you can make use of a timer that they have. You can do deploying and undeploying the verticals. Now, those things, I know it gets a bit more into the implementation detail. So I'll show some code to you, then it will be a little bit more clear, especially if you're new to this. So these are some of the examples we can use, right? So, okay, get a bit more than into the coding side. In order to write Vertex code in your Maven, then for your Vertex core, you can just do this dependency of the io.vertex core. Now, it has other integration libraries too, like with the web or with other, like even RxJava too. It also has a good integration with it because RxJava gives such a rich set of operators to operate on the stream. So Vertex is actually making use of the RxJava to help itself to do it. And you can also like make use of RxJava. It has a scheduler too. Anytime we deal with like asynchronous programming, we always also like bring in the scheduler to help us out, right? So those kind of things. So, and also, okay, so here, then there's also Gradle, if you're using Gradle, and you can also find this information online. And then for Vertex too, it's simple. That's why I was kind of bringing up the fact that it's simple. Not really that simple, but simpler than most, because all you need to do in your main, you can just start up like vertex.vertex, and that will essentially start up your Vertex in your runtime. And this, at this point, it's still local. Nothing going into the cloud yet. So, okay, so in order for you to like start up your control center, you can also add in different runtime, options. This is just an example, right? You can kind of set your worker pool size, for example, set some clustering, set your other kind of parameters you can also set to, and you can look up their information to find out what the other options are. And event-driven. So some example of an events, right? So Vertex is good for asynchronous, for event-driven programming. So example are like a timer has fired. That will be like an event that happens. So you can kind of handle it, using Vertex. And some data has arrived in a socket. Some data has been read from disk. An exception has occurred, or HTTP server has received a request. So essentially, too, event-driven is all in our current systems. And isn't it true? We are all doing systems, and it always have some action that leads to some, kind of trigger some, the results, right, coming out of it. So it's pretty, kind of like standard thing, event-driven. And event handling. So how does it work, right? So just some example. So you can do a Vertex set periodic. In this case, you make use of a Lambda that you can do a set periodic, and then an ID you can then print it out. For example, like that. And then you can also like receive an HTTP request, and basically you can write a handler to handle. For example, you start up the listener to listen on HTTP essentially. Then you can have a request handler that also in this particular case it just prints out hello world. Now in Vertex too, it makes use of a model called vertical. Vertical is essentially a unit of deployment in Vertex, and but the nice thing is that it doesn't enforce you or kind of force you to do it. Right? It's similar to actor model in Akka, and as some of you may know, right? Akka makes use of the actor model. The model is actually borrowed from Erlang in the 70s, essentially for the telephone industry, telecommunications industry. So that's Akka. But Vertex makes use of vertical. And as you can see too, it's actually highly encouraged to use the vertical because it helps in the deployment aspect, especially when you're dealing with, I have an example of a polyglot case, then you can actually deploy vertical that are vertical itself are written in different languages too. So it's kind of makes your, your application to be more versatile in this case. So these are some of the other things, right? The vertical processes, essentially incoming events over the event loop. So I'll quickly show that to you. And here, event loops, right? These are typically used in asynchronous programming models. Each event gets processed in a reasonable amount of time, so then it won't block the event loop. So once it receives the event, it takes care of things and maybe pass it on to some other processes to handle it or something. Then it can wait, kind of process the next things that are in line. So, and each event loop is attached to a thread. But in Vertex too, it attaches like 2 event loops per CPU core thread. That's how it works. And in event loop and vertical. So regular vertical always processes events on the same thread. And so no need to use thread coordination mechanisms to manipulate a vertical state. So from us doing, especially we're building applications that we're more concerned with how do we satisfy the business needs, then the lower level thread coordination is no need for us to worry about because the Vertex, the event bus will take care of those things for you. And for example, vertical can be passed like some configuration, and it can also be deployed multiple times. So let's take a look at this. This is a diagram I borrowed from the Vertex documentation. So as you can see, this is an example of a configuration that basically is passed into a vertical. The vertical will then deploy it, and it can be deployed like multiple times too, is what this picture is trying to show you. Okay, and Polyglot. Okay, so as I mentioned too, is that you can write your, you can have a Vertex Polyglot running in your, or Vertex runtime running in the same JVM, but the same JVM you can deploy like multiple verticals that are written in other languages. And again, my example will show that to you. And I think that's what I really like Vertex is. It's so easygoing. I think of it like an easygoing person. Yeah, you can do however way you want. We don't force you, but we'll support you. So how nice, right? If we have friends like that, isn't that nice? Nobody is opinionated, and that's what I like too. So, okay, so this is just an illustration, right? I talk about the Vertex Polyglot, and I'm actually currently doing a Twitch live streaming once a week on Wednesday. I'll give you some the information, but one of the things that I have started working on is a Polyglot example, and it's essentially an API gateway. All it does is funnels. It receives, I basically start off a HTTP server listening, and depending on the request, right, I route the request accordingly. And then behind the scenes, I have 3 worker verticals, one written in Java, the other in Kotlin, and then JavaScript. And I basically will route them accordingly based on the request. So that's an example illustration of the polyglot nature. And okay, so now we can get to that part. So that's good. Yeah, I was kind of wanting to make sure too. So I'll move this out of the way, and let me kind of show some quick example before I do the deployment. But let's, first thing first, I'm just going to assume let's not do the cloud part. Or actually, I won't run it, but I'll just show it to you first, right? So again, hello vertical. This one is a hello world. It's like anything else, right? We always write vertical. And I'm sorry, I don't know what I did to this. So everything is, you can see, it just cannot find the packages. But it works because I've done it before. So ignore the color on this thing. But anyway, the point is that doing, just like any example, want to show you a basic vertical, all it does is just say hello world. So I extend the abstract vertical, as I mentioned about. Abstract vertical is essentially, it's a, what you call it? I cannot remember. But anyway, it's a, it's essentially defines the vertical for Vertex. And so any application that wants to use it, you extend it. And as you can see over here too, I'm doing I'm importing IO Vertex core abstract vertical. But the thing is too, you find that in my, this is the Polyglot example. You can see too, there's also io.vertex.rxjava.core.abstract vertical. Because too is that it integrates, like I said, Vertex integrates well with RxJava. So essentially too, you can also use this version of this package, the Vertex and RxJava integration, and it also supports essentially the same as what Vertex core has too. So, okay, just a quick thing to show you first. But let's get back to some basic, right? Over here, over here, all I'm doing is just illustrate. I will just show you this one. Vertex, I will set a timer. So vertex.set periodic. Over here, just 5,000 milliseconds, which is like 5 seconds. For every 5 seconds, I'll just print out tick, this log, I log the information. And then another call that's common to do with Vertex is create an HTTP server. So again, this is just a basic illustration. Then I basically have the listener binds it, the listener to port 8080. And essentially too, making use of this nested way of coding, right? Then we do .create HTTP server, immediately do a request handler. So this request, so any kind of Vertex capability, we have to kind of essentially implement a handler to handle the requests that are coming in or do whatever it needs to do. And over here is just an example that I will just be sending back a response, and .end, it signals the end of this this request, and it kind of gets returned back to the caller is the hello. And in this case too, then it does a listener on 8080. So as you can see, it's quite simple. And then over here in main, all you need to do is to start up the vertex.vertex control center. And then all you will need to do is doing the deploy vertical. So that's why it's crucial that, no, I shouldn't say that crucial. It is very highly recommended is to implement your Vertex example or Vertex component to extend the vertical, because then you can immediately make use of their deploy vertical to handle it. So now I would not run this at this point, but as you can see, when I run this, then it will essentially will start up the HTTP server, and also then every 5 seconds it will print out to the logger, just a message tick like that. And the thing is, I wanted to show, or actually, okay, so I think that's pretty good. But I want to also quickly show too is this example of the polyglot nature, polyglot example, as I mentioned to you. So over here too, as you can see, it's I'm making use of also Vertex again has the configuration that I basically have a file that's called config.json. So it's just a list of JSON objects that essentially it's like my environment variables, right, for it. So basically I can then leverage on Vertex the config capability to read in this this config.json and also listens for any changes. And it can do its hot deploy. If you're, your server is running, you want to change something in the JSON file, it will immediately be picked up and feed it into your server. Your running process rather than you having had to stop and then restart. So that's what it is. So, okay, so let me kind of quickly go over. As you can see, this is my gateway. I extend the abstract vertical. Now, there is a lot of details in here, which I won't go into a ton of detail, but you'll notice too, as such too, I'm making use, in another talk, people were saying, why are you using atomic integer? Because I'm just using this for handling a bit of a measurement. I'm doing a metrics too. So as you can see, metrics class will basically measure how long does it take, for the response to come in, and how long does it take to respond back. And that's essentially, it's just a simple program. But metrics part, but I wanted to show the polyglot part. So over here too, as you can see, any Vertex program, you do a start, you override the start. And basically in here too, my config, right? I get the config.json, which I just showed you. And basically I leverage on the config store options and set up my, setting this to map to my JSON object in memory. So, and then I do a config retriever, and essentially then I create it and basically binds it, right? It's sort of like bind it, and you basically add all of these information into your file store in memory. It sets things up in memory. So, okay. So now, if it's all good, then you can see too is that I will just call this method called startup. So that's what it is. I take whatever configuration it is, I pass it to my startup. Now, as you can see too, there's also config retriever that I'm setting up a listener for. As I mentioned too, if any changes in the configuration file, you don't have to worry about it because this already takes care of it in memory. It will just be process configuration changes on the fly. That's what it is. So again, this is a simple illustration of this. But let's take a look at my startup. So over here now, as such, to want to point out, you can also override the stop. Anything if your server, your process stops, you want to do something. Over here, I'm doing a worker executor shutdown, and I unsubscribe to my metrics thing too. So things like that. So okay, so this one is process config, but that's fine. We won't go into detail. But like I said, on the startup, okay, so when all is good, I read in my configuration, and then I call my startup. So in the startup in here, I essentially will start up my router. So my router will take in the control center, but two is that my router is also setting up like a CORS handler because I'm handling all of the, routing, right, for the different method or kind of commands that comes in. I want to do health check. I want to check my API resources and certain things. But again, this is a simple example. In real world, you can do anything that you need, right? Okay, so I can also set up my router the CORS handler in here. And basically, too, you see that there's also a sock.js bridge because I have a JavaScript component that I'm calling. So in order for the messages to communicate between my JavaScript and my Vertex, I'm making use of a sock.js bridge options in here. So, but as such, I'm still in process working with this. So haven't got this one all sorted out yet. So you can see there's to do. I need some testing, things like that. So again, this is just to quickly show you. And ultimately, after I set all of these things down, and this is the part then I set up create my HTTP server and set up my request handler and accept all of the, the request that comes in. And essentially too, in my .listen, I'm actually doing the deployment of each of these worker vertical. So deploy Java worker is my Java vertical, deploy JS worker is my JavaScript, and then deploy Kotlin. So okay, let's take a look. Now, some of these other things I won't have time to talk so much, but as you can see, you can also be manipulating the event bus and handles all the messages accordingly. So also like a quick thing, then deploy Java worker. Let's take a look at this example. So once I start this whole thing, then it's basically, as you can see, the polyglot side of my Vertex control center, all it needs to do is basically call a vertex.deploy vertical and pass the name of my Java worker vertical to it. And then the options, as well as then there's also a result that needs to happen, right? So over here too, what I'm doing in here is that, if this, actually I should say not result, the response comes back. If it's failed, then I will print out something, right? If not, then it's all good. Then I basically will deploy verticals. And as you can see, I'm doing some metrics, so I'm just doing that in here. But in real life, you can do whatever you need. So the point is that trying to illustrate to you to do a deployment of like polyglot deployment is actually quite nice, having this kind of a setup. So okay, so that's that. And also quick thing, right? And over here, deploy Kotlin. So same thing. It's essentially the same kind of boilerplate code. You can just do deploy vertical, and it's a Kotlin worker vertical class that you're deploying. So, and if it's JavaScript, then you do a deploy vertical worker vertical.js. So, and then over here, right, you might be wondering, then how does it look like? So if you're familiar, right, with Kotlin, then you see that. So this is just then a Kotlin implementation of a Vertex component. So, and I won't go into all the details. So, but that's what is essentially being deployed by my Vertex. And then if this one is essentially my Vertex, the Vertex for the event bus that you do need to include into your whole resources package for processing like JavaScript. So if you're familiar with that, but otherwise too, this is my what gets deployed by my Vertex vertical. So okay, so that's that. So these are like again some examples for you for the Vertex part. And now let me then get back. I hope I have some time, right, Michelle? Do I have time? So Let me also
we are
then
on
get
time.
back to
You have 1 hour, so you can, if you have, so don't worry.
Okay, great. Thank you. Thank you. Okay. Yeah, 1 hour. Okay. I still kind of want to make sure. I want to show this, the deployment part and something on the cloud side. So,
Go ahead.
okay. So that's what I'll do. Oops. Yeah. Yep. Thank you. So, okay. So now, okay, I showed that, and that was, I just showed you those. Okay, now it gets to finally, you were like wondering, well, you're talking about deploy to cloud, when is it? So now is the time. So, okay, now, all of those we talked about already set the stage, but in order to build and deploy to the cloud, well, first of all, just want to invite to you earlier, I think I point out to you, you can sign up for the IBM Cloud. So this, if you want to sign up, again, you can save this link or maybe scan this QR code for now. You can sign up later too, because if you join my workshop later, then we have more chance of also trying it out too. So again, I'll give you information on those. And I'll also make these the slides available to you too. Then you can also reference this. And here, so some serverless deployment. Now let's get in a bit into the serverless deployment. Earlier, we talked about building apps, all these things is complicated enough. Now get into the serverless deployment part. So as such, right, serverless is kind of came out since the cloud computing has come up, right? And so serverless, it doesn't mean that there are no servers, but it just means to the application developers, right, like ourselves, we don't have to worry about the server part because the server is essentially your infrastructure. Let's say if it's Kubernetes and basically it has all the infrastructure there. That's the server. So serverless to us, but it's not serverless to the infrastructure. So that's serverless. So it's really a cloud native computing, new terms. And essentially too, it helps you to build, deploy, run, and operate scalable applications in modern dynamic environments. So as such, right, scalable, as you can see, reactive is kind of fits very well in this environment. Reactive, one of the tenets is scalability, elasticity. So it's basically to that aspect of reactive can also be leveraging on your cloud infrastructure to help with that too. And so that's that. And then, okay, so serverless deployment. And there's also some just basic understanding of cloud environments. As we know, there are public cloud and private cloud or hybrid cloud. So private cloud, let me highlight too. I think most of, and also too, folks also have heard of like on-premise, right? On-premise really means it's the systems that's contained within an organization. Let's say you work for a company. All those are like within, your private networking environment. It's not exposed to the outside. That's private. So in some sense too, you can also be running cloud privately, right, within your own networking. So a lot of times too, I'm aware of companies like financial companies or maybe telecommunications company. They have certain parts of their whole systems that are all running in private cloud, and primarily because of security concern. They don't want to have it be exposed to the outside in case there are, cyber criminals trying to steal them, that type of stuff. So that's private. And then of course, public too, is what we are all aware of. Public means everybody, from anywhere can access it. Then there's also the hybrid version of, some systems are private, some are public, kind of hybrid kind of ways. And I believe most of the companies are probably having more of a hybrid kind of environment these days. And so a bit more about serverless deployment. We're dealing with some application techniques that are involved with this. So containers, microservices, and serverless functions too, and immutable infrastructure, and also declarative deployment, meaning that in your deployment, you essentially don't have to like write and tell it other than maybe in a YAML file, right? That's very commonly used, right, in Kubernetes, in which you write the YAML. It's much like a enhanced version of XML type of, even though people don't like the word XML anymore in the modern world, right? But anyway, it's just markup language for doing declarative deployment. And some example build and deploy. So to build a container image, so essentially too, now what I'm going to illustrate quickly is basically take the Hello World application, take it and basically deploy it. First, do a Docker build, because anytime, right, we work with Kubernetes, it's actually you kind of deploy it as a container. And okay, and that's also news too. A few days ago, right? Kubernetes, they announced that they will no longer support Docker. But so it kind of like send a bunch of like kind of like shockwave to the world, and basically, I think Docker would still be support. You can still run your Docker containers, but it just means that in the long run, Kubernetes won't be supporting Docker so much. But still, there are lots more to read about in details too. That's another thing. But here though, with my example, because I developed this before the announcement, which this Docker thing was just a few days ago. So my example is still making use of Docker, and I already have my image built, on my Docker Hub too. So so essentially too, this is an example. So you do a Docker build, and then -t is basically your account, right, on Docker Hub. And okay, so over here, it happens that I was at another kind of a event called Comash. So I just name it Comash and basically do a dot. And that's what I do, is essentially build the container on my local machine. And then basically the next step is to push this container to the Docker registry. So once it's up there, you can basically then on back to your side on my cloud, right? Using OpenShift. OC is the OpenShift client on the command line. Just do an apply and then dash file name, and you give the service.yaml. So let's take a look then at the YAML file. Let's see. I have to kind of do this to kind of get back to my service YAML. Where is it? And I apologize if I am. You know what? I might have accidentally closed that. Oh, no, I did not. Okay. Okay. So this was actually another workshop that I've done, and but we can take a look. Is essentially the same thing. So, so over here too. So this is an example of a YAML file. So if it is new to you, right? So you basically in this particular example, for doing serverless deployment, I have chosen to use Knative, which is a serverless tooling, if I may say so. That's some of you are familiar with. So that's the Knative I'm using. It essentially helps you to do serverless deployment. And the thing is, deployment to Kubernetes in particular. So Kubernetes, with this Knative tooling, there are actually two components. One is the Knative serving. Serving handles the deployment part, also handles the versioning too of your system. Because think of it, right? Now we are kind of, when it talks about deployment, we're really getting more into DevOps side of the business. We have to also like handle, in reality, if you deploy a component in runtime, you have to manage the version, manage a lot of things. So essentially, Knative helps you in managing those things. So, and over here too. So like this is kind of like a very basic version of a YAML file. You specify that it is a service, and then metadata in here is that it's called hello world Vertex. And my namespace I happen to be using is called JFall Workshop. And over here too, now you can see too, then you write your spec. So the template over here too has the name that refers to my version of my instance. It's hello world Vertex v1. Now that's important too. This one, the name here, you do need to specify the version, because that's how too is the Knative be able to keep track of your versioning too. And then over here too in your spec, then there's also the template. There is another spec to basically have the containers information. Now what we just built too, actually, well, it's actually I didn't update it properly. But the thing is too, just now in my slide, I have it like Docker. I say push it to my Docker Hub. So this is my Docker Hub name, Gryglesky. And then basically too, then I specify the name of the container, which I've kind of pushed to. And then over here too, you see the env is basically the environment that I can pass the environment info to the containers is through the env directive here. And then I just have a name of target, and the value is this, right? And hello world and like this. So that's the YAML file. So okay, so I know I have about maybe 5 minutes or so now, and let me then quickly bring up, quickly bring this up. Oh, and that's the one thing. it's been a bit of a challenge. We're working with newer technology, OpenShift, and sometimes, I think also now today is a Saturday, sometimes they have things like being maintained, like maintenance mode. So you can see to over here, like operators degraded. So don't worry about it. I think in normal times, it would be better. But like I said, weekends, there are maintenance going on. But let me kind of quickly start from the beginning too. So now, when you sign up for an IBM Cloud, and as I mentioned, we are running certain workshops that you are all welcome to join from anywhere in the world. And then you can basically make use of some free Kubernetes OpenShift cluster to try things out too. So I will send you those information, or you can stay in touch with me and follow me. I'll give you those information. But see how kind of interesting it is, right? You get into the IBM Cloud, and essentially too, you go to Kubernetes and then I go to cluster. And this, like I said, I'm already doing a lot of shortcut. I can't do it step by step, but just to show you, I've already set up my OpenShift cluster. I name it Mary G-KS8SOS and like that. So you can see for running Knative, we must have to have like 3 worker nodes, and that's the kind of requirement, kind of minimum. And like I said, in real life too, these does cost money. But the thing is, you come to our workshop, we'll give it to you for free for 48 hours. So okay, so anyway, so this kind of, you can tell, I'm running a relatively new 4.5 version of the OpenShift. So, and these are different zones and all these things. And I set this up back in October, all these things. So there's also logging, monitoring, and like some of the key management service too that you can also set up as if your subscription gives you the capability. So now I'm using an internal available copy. So I do have all of these kind of capability. So, okay, so now if you go over here, click on OpenShift Web Console. Now I've already done it because in real life, it takes a few minutes. So, and we don't have enough time. So like I said, over here, this is more information about my cluster. And I wanted to quickly show you. There's in OpenShift, right? In the OpenShift Kubernetes world, every time when we talk about you interacting with Kubernetes, you interact through using their Kubernetes API. So in order to work with these APIs, actually there are operators, they call it. So don't mix it with the reactive operators. That's different. Reactive operators work with the reactive streams. But here, operators in OpenShift, we work with the Kubernetes API underneath the hood, right? So, okay, so there are operators that are already written up, essentially, that will interact with the Kubernetes underneath. And then in OpenShift, as you can see over here, I have my operator hub. Let me maximize. You see it better. Okay, so operator hub is essentially what gives you a bunch of already written up, like customized, right, kind of preset operator. And it sometimes, unfortunately, this might take a bit of time. But like I said, because of the deployment part, I want to kind of still quickly show you about this. And it may take some time. But the point I'm trying to make, let's go to install operator. Okay, so operator hub will show you a whole list of things, but I have already installed, oh wait, where did it go? See, sometimes with maintenance, it doesn't show up, but the install operator should also show a Knative operator. So in order for you to make use of Knative on OpenShift, you do need to essentially install the Knative operator, is what I'm trying to show you. Okay, so no worries about it. This, again, if you join a workshop, we will show you in more detail. Now, let me then go to how do you may be wondering, well, how do I actually interact with OpenShift? So this actually, I think it says it wants me to close it. Are you sure? Oh, okay. All right. Well, I guess unfortunately I opened it too soon and it has a timeout with that. So let me do this. Go back to here. This one, right? In your cloud IBM Cloud shell. There's this thing called that it opens up a shell for you, and that's what we were looking at, and that's how we kind of open it. Now the thing is, it may take a few seconds, but again, let me for the interest of time, because I don't have as much time left now, I just want to like quickly show you this. So once you bring up the cloud shell, it's actually quite convenient. You can then go back to your OpenShift console over here. It says manage or copy login command. So I do need to log in first to my OpenShift cluster on my cloud shell. So now it just takes a bit of time. Again, I go back to here. If you go into your OpenShift container platform, going under your ID, you can then see copy the login command. So this is what I'm going to do, and basically display the token. Then you can basically then copy this OC login, this token. Now I copy it and I bring it into my Cloud Shell. My Cloud Shell opens up, and you can see that now I'm connected, right? So you can just say like this, right? Oh, I'm sorry. I think, Michelle, I may be running out of time, right? I even have my timer that's kind of ringing. So, but the point I'm trying to make, I think we're almost at the end. Like I said, right? This is magic, but the thing is to do in order for you, now let's say you are interested in here, all you need to do, right, is just like a shell. You can basically do a git clone of your project. Then with that project, you have your YAML file. Your YAML file, as if you recall, we were looking at the YAML file that specifies, where your container is and where to deploy to and all those things. And basically, let's say you have your YAML file here. All you need to do is OpenShift client and then basically do an apply and then do a F and basically the file name, let's say is jcon.yaml. And right now I don't have that file, but I just wanted to illustrate to you it can be done as simple as this. So these are the steps for you to be able to deploy just a simple basic example onto OpenShift. Now, if you are obviously in real world, we are working with database with all of those things, that will require another set of like complicated setup too. But I do not have time today to do it. But I hope to be able to maybe in my Twitch stream be able to do something more in-depth too. So please do come and join me. But in the meantime, let me kind of go back to my this here. So then you know how to contact me too. So I just want to take the time to say thank you to all of you for coming to sitting through with me and being so patient with me. And want to invite you to join my live stream on Twitch. It's on Wednesday. It's actually GMT -6. I thought I changed it, but I think we're in the same time zone. So on the twitch.tv IBM developer is where you can find me on Wednesday, like roughly 12:30 to 1. That time frame. And also, if you follow me on Discord, we can have more conversations on Reactive, on the cloud, and on everything. And also, too, I will tell you, every week I tell my followers, too, to say, I'm going to run a Twitch at this time, and people will then sign on, too. So want to invite you there. And these are some additional resources if you want to read up more on the reactive systems, Knative documentations, Red Hat Knative tutorial, and deploying serverless apps with Knative is over here too. Now, I'll make these available to you, but I want to thank you. I think this is it. Yeah, that's right. So I'll leave it up here, back to here. And I want to thank you all, and I have gone over a little bit time. So thank you, Michelle, for not rushing me. And so it's been so great. And thank you so much. I hope it's useful. Or does anybody have question? Let me see. How do I get to the, do I go to the stage? Oh, okay. Wait.
Yes, we have some questions about your yeah.
Oh, okay. Yes. Now I see. I go to the stage, right? That's where I have. Let me see. Let me kind of make sure I go back to the beginning part. Okay, those are in Spanish. Some of them are in Spanish, right? Oh, okay, I see. Yeah. Okay, my Twitter. Yes, that's right. Thank you, Michelle. I see that you have that. And link. Yes, and I will, again, Michelle, I will be uploading this. I believe, do I give that to the organization here for my this slides? I will convert it to PDF format, so then I can give that to you. Okay. Okay. Oh, you have some books. Yes, Sergio, you asked some good question about the books. Okay, so what I would do is that on my slide, I give these kind of more like highlight, of what I've talked about. But what I'll do is I'll add in another slide with more information on reactive streams, as well as some more information. I think this slide is more on Knative and the deployment side. So for reactive too, I have another. Actually, I have another 2 slides I can give you too of materials. So yeah.
Okay.
And,
So thank you, Mary, for your speech. It was very interesting, super amazing, and I'm very glad that the time that we are in perfect timing. So
Okay.
that's amazing, and really, we don't have any questions. The only was the whole or how you can study Java for React, because we have some front end like prime faces, like time leaves. So the point is that the kind of books or resource that you can share with us
Sure.
about how you can, how we can start to study Java and React.
Sure. Yes, as I mentioned, Sergio was asking too. Good question. I will actually, I should update my slide here to, like I said, I will include additional links for reactive streams, reactive programming. I'll update them, and I will then have this document, this slide deck ready and in PDF format. Would that work for everybody if I do it in PDF? Because right now I'm running in Keynote. Maybe not everybody can read Keynote, so I'll do it in PDF, and then like I said, I will update it. I will share it from my Google Drive, but I have your contact information, Michelle. So I will send you the link, and then you can then share with everybody. Yeah, does it sound good? Yeah. Okay.
Sounds good. And so we're going to. We need to pass to the next speech. To the next speech, so you can say goodbye to everyone because we finished today. So
thank you. Okay, take care, everybody. Thank you again. Have a good day.
Okay.
Bye-bye.
Thank you. Have a good. Bye
Bye-bye, Michelle. Thank you.
Bye-bye. Thank